Alright guys, yesterday we learned how to find the inverse of matrices using row transformations, similar to what we did in the Gauss-Jordan method. Today we're going to do that we're going to take that one step further, and we're going to use inverses to help us solve systems. Okay, so the first thing that we're going to do is we're going to set up our system into a matrix. So we're going to make a coefficient matrix, just taking the coefficients in front of our variables. Then we're going to set up a variable matrix. And then lastly, we're going to set up our constant or our answer matrix. This shouldn't be too surprising to you. We've done similar things earlier in the chapter, but now we're officially using matrices to help us solve systems. Now I'm going to label these different matrices. I'm going to label our coefficient matrix as matrix A. I'm going to label our variable matrix as X, and then our answer matrix as B. And so basically what we have here is we're looking at matrix A times matrix X equals matrix B. Now our goal is going to be to solve for X because we want to know X and Y. We can't divide by a matrix, but what we're going to use is we're going to use the inverse. So X equals the inverse of A times matrix B. This is what we're going to use at the end. First, we have to find the inverse of matrix A. So for that, we're going to use row transformations. We'll set it up. Okay, and there is more than one way to do these, but today I would suggest just following my way. I'm going to multiply the first row by -2 and the second row by 5. So I'm going to get -10, -4, -2, and 0, and then 10, 15, 0, and 5. So if I add those together, I'm going to keep the first row the same. I'm working on getting a 0 in the bottom left position. So if I add these two together, I get 0, 11, -2, and 5. Alright, then I'm going to work on getting a 0 in the top right position. So I think I'll multiply this one by 11 and this one by -2. So we've got 55, 22, 11, and 0. And then 0, -22, 4, and -10. And then when I add those together, the bottom row is going to stay the same this time. So I get positive 55, 0, 15, and -10. And now my last step is just going to be to multiply the top row by 1 over 55 and the bottom row by 1 over 11. So now my inverse is 3 over 11, -2 over 11, -2 over 11, and 5 over 11. Okay, that's the part that we did yesterday. Now what I'm going to do is I'm going to take that inverse and I'm going to follow the formula X equals A inverse times matrix B, which is the answer matrix. So this is the new part. Okay, we talked about how to do the inverse yesterday. Now I'm going to multiply that by the answer matrix, which was -1 and 15. And then remember how to multiply matrices. You're doing row times column. When you do that, you're going to come up with X equals -3 over 7. So the ordered pair solution would be -3, 7. Okay, let's go ahead and try number 2. So we're going to start the same way. We're going to set up the matrix with a coefficient matrix. So we've got 1, 3, 2, and -1. Then an answer matrix. Again, we've got our variable matrix. We've got X and Y. And then we've got our answer matrix, which is -12 and 11. Okay, the first thing we want to do is use our row transformations to find the inverse of matrix A. Alright, I'm going to go ahead and try to get a 0 in the bottom left position. So I'll multiply the first row by -2. I'm going to leave the first row the same. And when I add those two that I just multiplied together, I get 0, -7, -2, and 1. Alright, now I'm going to try to get a 0 in the second column, the first row. So I think I'll multiply the first one by 7, the bottom one by 3. We got 7, 21, 7, 0, and then 0, -21, -6, and 3. I'm going to leave the bottom row the same this time. And the top row, when I add together, I get 7, 0, 1, and 3. And then to get the ones, I'm going to multiply the top row by 1/7 and the bottom row by -1/7. So my inverse matrix, now I've got my 1, 0, 0, 1, is going to be 1/7, 3/7, 2/7, and -1/7. Okay, as soon as I have that, then I'm going to solve using x equals A inverse times B. So I'm going to take that inverse matrix and multiply it by my answer matrix. This is really the only new step that makes our work today different than our work yesterday. And you have to think back to when we did the multiplying matrices work. So for this one, multiply, we get -12/7 plus 33/7. And then we're looking at -24/7 minus 11/7. 33 minus 12 is going to give you 21/7. And -24 minus 11 is -35/7. So that simplifies to be 3, -5. Alright. Okay, it's going to be our 3 by 3 system of equations. So again, we're going to start by setting up our coefficient matrix. Now this one is a little bit unusual for a 3 by 3. It's got some missing terms. Remember to fill in those missing terms with zeros. So in my first row here I've got -4, 2, 0. In the second row I've got 1, -1, 2. And then in the third row I've got 0, 1, 4. Okay, hopefully those zeros will make our life a little bit easier when it comes to finding the inverse. This time we have 3 variables. We have x, y, and z. And then again, that's equal to our answers, or our constant matrix, 12, 7, and 20. Okay, now we need to find the inverse of our 3 by 3 matrix using the row echelon form. It's a little bit more work, but hopefully the zeros will help us go a little bit faster. Alright, first I'm going to find the zeros in the first column. So I'm going to multiply the second row by 4, and the third row I already have a 0, so I'm pretty good to go there. I'm going to use the first row and the second row. And when I add those together, keeping the first row the same, and in the second row I get 0, -2, 8, 1, 4, 0. And the third row was already good to go. Alright, next I'm going to focus on getting the zeros in the second column. So if I add the first and the second row together, I'm going to get a 0 in the first row. So I'll go ahead and just add those two together. So I get -4, 0, 8, 2, 4, 0. I'm going to keep the second row the same because I don't need to get a 0 in that row. And then in the third row, I'm going to multiply that one by 2 and add that with the second row. So I've got the second row exactly the same. And when I multiply by 2, I get 0, 2, 8, 0, 0, 2. So when I add those, I'm going to get 0, 0, 16, 1, 4, 2. Alright, lastly I just need to get zeros in the third column, so I'll multiply both the second and the third rows by -2. Excuse me, the first and the second rows by -2. And that way when I add it to the third row, the 8s will become -16s and they'll become zeros. So I've got 8, 0, -16, -4, -8, 0. Then I've got 0, 4, -16, -2, -8, and 0. And I'm going to add both of those to the third row. Alright, so the first row is now 8, 0, 0, -3, -4, 2. The second row is now 0, 4, 0, -1, -4, 2. And then the third row, I'm keeping the same, so it's just 0, 0, 16, 1, 4, and 2. Okay, then lastly, I just need to get the numbers that are on the diagonal to be 1, so I'll multiply the first row by 1/8, the second row by 1/4, and the third row by 1/16. So that's going to give me what I was looking for on the left-hand side. And on the right-hand side, I have -3/8, -4/8 reduces to -1/2, and 2/8 reduces to 1/4. Then in the second row, I've got -1/4. -4 divided by 4 is -1, and 2 divided by 4 reduces to 1/2. And then in the third row, I've got 1/16. 4/16 reduces to 1/4, and 2/16 reduces to 1/8. So now I've got my 3×3 inverse. The last part of the problem has me solving for x. Remember that x is going to be A inverse times B. So I've got my inverse that I just found. It's all of these fractions, -3/8, -1/2, 1/4, -1/4, -1 and 1/2, and then 1/16, 1/4, and 1/8. And I'm going to multiply that by matrix B from the top, which was 12, 7, and 20. And when I multiply those, I get my final answer, -3, 0, and 5. Alright, so basically today, you're doing the same thing that you were doing yesterday, finding the inverse of the coefficient matrix, and then you're just taking it one step further and multiplying that inverse by B, your answer matrix. Good luck. If you have any questions, we'll talk about it tomorrow.